Okay, Calc, this is the video for 8.3, which is the last section in Chapter 8 that we're going to talk about. There won't be a test over this chapter, though. We're just going to move right on to, I think, Chapter 13. I have a couple sections to go to from here, but this is log functions and antiderivatives, or integration. So you need to remember antideriv. That's what we're doing in this section, okay? So they have one rule going on here. This is only a front side. There are a couple problems on here. We're going to skip number 5, though, so we'll just do 1 through 4 and then 6 and 7 on this, okay? So one thing that I want to talk about first before I get into these rules is that when you're taking the derivative of ln of 2x, okay, we said the bottom part stayed the same, okay, and then you take the derivative of the top, and that became 2, which is, the 2's cancel out, so that's just 1 over x, right? So the derivative of ln of 2x is just 1 over x, okay? Now, if we're looking at the derivative of ln of negative 2x, okay, same things apply. Negative 2x goes in the bottom. The derivative of negative 2x is negative 2, and those are going to cancel out, so it's just 1 over x again. So basically, these two things have the same derivative. They're both positive when we take the derivative of them. So what happens is, when we have 1 over x, like what we had here, what we need to do then is say that his antiderivative is not just ln of x, but it's ln of the absolute value of x, because I don't know if it's a positive or a negative. So that's why they put absolute value bars here, okay? Normally they don't have you take derivatives of ln of absolute value stuff, so if like they say ln absolute value of 2x, they don't focus on that as much, but when you're taking the antiderivative of 1 over x, you do need to put it into absolute value bars, okay? So this is where the absolute value comes into play and is really important. Same thing here, 1 over u is, the antiderivative of 1 over u is ln of u plus c. And the reason why they write this here is they're saying you can use substitution. And this would be the format that you use it in. So you would convert everything to u's and then take the antiderivative. So that's kind of set up for substitution, okay? So example 1 here. We have the antiderivative of 2 over x, okay? And so what I want to do is I'm going to cheat real quick, and I'm going to, anytime you have a constant number, you can always lump him out in front, okay? So I'm going to take that 2 off the top and put him out in front, okay? Well then, we know that this guy right here, the antiderivative of 1 over x dx is just ln absolute value of x plus c. And since constants don't do anything, they just hang off in the front, that's what he will look like, okay? So that's kind of a cheat method. Anytime you have a constant or something that's just hanging out there that's not attached to any x's, by all means, bring them out in front. That's a-okay, you can totally do that, okay? Now number 2, it's not just 1 over x, it's 1 over 2x minus 1. So this is going to be one where we're going to have to use substitution, so u and du, okay? And we want to set our u equal to our bottom number so that eventually we can write this as 1 over u, right? So 2x minus 1 is going to be my u. Okay, and then the derivative of that, 2x minus 1, will just be 2 dx, okay? And then I'm going to start substituting, okay? So I need my integral symbol first. So that's gone, okay? 1 over 2x minus 1 will become 1 over u, because 2x minus 1 is u. So he is substituted in for. And now I need to replace the dx, okay? But I want just dx by itself, because I have nothing else to replace but dx, so I need to lump this 2 to the other side. Okay, so the 2 going on the other side will make this 1/2 du equals dx. So that means if I have dx and I want to replace him, I have to replace him with 1/2 du. Okay, so du needs to go in here, and again I'm going to cheat and put that 1/2 out in front because constants don't do anything. Okay, and then this just follows along the rule with substitution up here with number 2. So if I take the antiderivative of 1 over u du, it is ln absolute value of u plus c. That 1/2 is just hanging out there in front. And then there's one more thing that I need to do, which is switch it back to x's. So I need to replace that u again. So 1/2 ln absolute value. U was originally 2x minus 1 plus c. Okay, so there is that. I've switched him back. So hopefully that wasn't too fast. Again, if I'm going too fast, go ahead and replay this video or replay this part of it. There you go. Number 3, let's see how this one works out. So we've got a whole lot of messy stuff going on here. Let's see. I'm going to try u and du and see how this works out. Okay, u we want to set the bottom equal to the bottom, so we have x cubed plus x is what my bottom is. Okay, let's try taking the derivative of him. So x cubed, the derivative of that is 3x squared. The derivative of x is 1, and then that is dx. And look at that. That's beautiful because that's exactly what the top part is. 3x squared plus 1 dx is equivalent to what du is. So I can take that whole thing and just lump it in there. Okay, so I'm gonna start replacing things now. So I have my integral symbol. He's gone. Okay. The bottom number, x cubed plus x, was just u. And then this entire 3x squared plus 1 dx, okay, is equivalent to du. So that whole piece is gone up at the top there. Oh, this guy's gone too. That whole top part piece is gone. Du is the only thing that I have left over, but then this is a 1 here, okay? And then I need to find the antiderivative of that. So what is the antiderivative of 1 over u? Not the derivative of 1 over u, but the antiderivative. Okay, we did that up here and every other place as well. Antiderivative is just ln, absolute value of u, plus c, okay, which is going to be ln, absolute value of x cubed plus x, plus c. That's what he would look like after I plug stuff back in. Okay, now, on each one of these, keep in mind that you can check your work to see if your derivatives come out nice. So this is my antiderivative. If I take the derivative of him, the bottom part stays the same, and the top part is the derivative of that, so 3x squared plus 1. Ah, that's exactly what my original was to start with. So I know that I did that right, okay? And you can check those on any of these up at the top here, and they will end up checking out, okay? All right, number 4, there's a little bit of work that we have to do on number 4, because if I look at the bottom part, x squared plus 1, if I take the derivative of that, that's 2x, and 2x doesn't show up in the top here. In fact, this top part has the same degree, it's x squared, as the bottom one does. Okay, so what I'm going to do to start with, and I know you're not going to like this, is I'm going to divide. I'm going to use long division real quick, just once. Oh, and I'm going to put plus 0x plus 1. So that I have that placeholder in here, okay? And then we're going to figure out what he is. So x squared, what do you take times x squared to get x squared? 1. 1 times x squared is x squared. 1 times 0x, and 1 times 1 is 1. Okay, so that's what I have going on there for my long division. And then I'm going to change the signs for everything. So my x squared goes away. I have x minus 0x, which is just x. And then I have 1 minus 1, which is plus 0, if I want to do it that way, okay? And x squared won't go into x, so what this will end up looking like is plus x, really x plus 0, or just x over x squared plus 1. Okay, so hopefully I went through that not too terribly fast. So what we're going to do with this then is I'm going to write my integral as 1 plus x over x squared plus 1 dx, and that's what this guy is equivalent to, okay, if we do our long division, okay? Now, this piece, since I have a plus sign in between there, I can separate him into 1 dx, and I can separate this guy into x over x squared plus 1 dx, okay? So I just kind of bump him into 2 pieces, okay? So this part is the one that we're going to use that, this substitution on. But this one is saying, okay, if the derivative of something is 1, what will the antiderivative of that be? Or how do I get back to that? What do I take the derivative of to get 1? Okay, and that is just going to be x. The derivative of x is 1, so the antiderivative of 1 is x. Okay, so that's done. And then I need to do some substitution here. So I'm going to do it up here. I'm going to call u the bottom part, which is x squared plus 1. And then du would be the derivative of that. So the derivative of that is 2x dx. Okay, and now I'm going to start to substitute. So my integral symbol goes down. Okay, the bottom x squared plus 1 is now going to be replaced with u because that's what I've called it. And then I have x and dx that need to go away. x and dx need somewhere to go. So x dx shows up in here, but the 2 does not. That means I need to bump the 2 to the other side. So this will be 1/2 du equals x dx. Okay? All right, I'm going to put the 1/2 on the outside. Du is going to go here. That will get rid of the x and the dx. And then I just need to put a 1 up at the top here. I really hope I'm not going too fast. I'm kind of rambling on and on and on and on and on. Okay, so now I need to take the antiderivative of 1 over u, which is ln absolute value of u, plus c. I need the 1/2 out in front. X is just chilling on the front there. And let's see, anything else I need to do? Oh yeah, I need to switch this u back. So x plus 1/2 ln absolute value. U was originally x squared plus 1 plus c. And now he is done. Okay, so that was kind of a longer problem. Kind of an ugly one that we had to start out doing long division with. Okay, all right. Let's see, I'm going to skip number 6 also, just so this video isn't terribly long. Number 7, find the area of the region bounded by the graph of that function. Okay, so basically what I have going on here is I don't know what that function looks like. Maybe he looks like this. I don't know, something, whatever. Okay, and I want to find the area underneath of that. Okay, so I don't know what he looks like, but we're going to say that's what he looks like. And it says bounded by the x-axis, which is this guy here, meaning that he's not going any below, just like normal. We don't ever go any below that line. And then bounded between 0 is less than or equal to x is less than or equal to 3. That just means that the leftmost point is going to be 0, and the rightmost point he's bound by is the number 3. Okay, so those are going to be my lower and upper limit for my integral. So I have the integral from 0 to 3 of this stuff, x squared plus 1. Oh my gosh, we just did that. Didn't we just do that? What? Okay, well done. And dx, I need dx on the end of there. Okay, so we just did the antiderivative of x over x squared plus 1 dx. Isn't that right? And we found out that it was just this part, right? Or really this part right here. The x came from the 1 in the front, which we didn't have, or we don't have in this problem. So I'm just going to copy that down. 1/2 ln x squared plus 1. Oh, we can totally cheat. Okay, now, remember that when you have limits of integration, so like from 0 to 3, we don't have to put that plus c in there because we're actually substituting values in. So here's my antiderivative, and I'm going to plug in the values 0 and 3. So that's the notation that I use. This basically says I've taken the antiderivative, but I have not plugged my numbers in yet. Okay, and that's what I'm going to do now. There should be a bar. I started writing in parentheses, but those are absolute value bars. Okay, so last thing we need to do, we got to cheat a little bit. That's kind of exciting. 1/2 ln absolute value. I plug in 3 first, and then I subtract the 1/2 ln 0 squared plus 1. Okay, I'm going to simplify some things first so that I can plug this in a little bit easier into my calculator. 3 squared is 9, 9 plus 1 is 10. So really this is 1/2 ln, and I don't need absolute value bars anymore. In fact, I can't plug those into my calculator anyway. You might be able to, I don't know. But absolute value of 10 is just 10, so we can get rid of the absolute value bars. Minus 1/2. 0 squared is 0, plus 1 is just 1, so I have ln of 1. Okay? All right, and then... Okay. I have 1/2 or 0.5. I can type it in as 0.5. That might be easier. 0.5 ln of 10 minus 0.5 ln of 1. And that is going to be 1.15 as an area. So that would be like units squared for my area under the curve. Okay. All right. So there is that. And Yeah, that was antiderivatives of log functions. So we are now done with that. I will also tell you that you guys have on your unit circles, and if you don't have this, you'll actually be getting another one for a graduation present whenever I can get those to you. But you guys have on your unit circle, let's see if this has all of them on there. You guys have rules on the back side of your unit circle that have derivatives and antiderivatives of all of the major types of functions. Come on, open. Okay, so here's a copy of the unit circle that you guys either have already or will be getting from me. But basically the front side of this is all a lot of trig stuff. So it has all the identities like tangent is sine over cosine, sine is 1 over cosecant, that type of thing, Pythagorean identities. This is a lot of stuff that we used in trig. But then this back side has kind of a cheat sheet for derivatives and antiderivatives. So it has the constant rule, where when you're taking the derivative of 5, that's 0. The power rule, x to any power is n times x to the n minus 1. Product rule, quotient rule with examples of each one. And then it has the derivatives of natural log and exponential functions. Also there, they have the chain rule, and then implicit differentiation, which involves like y's and x's at the same time. We did that. First derivative, second derivative, what they mean. Derivative is slope of a tangent line. Going down to the bottom is the antiderivatives of each one of those. Okay. If you're finding the area under a curve from A to B, it's f of b minus f of a. And then basic rules for integration. So 1 over n plus 1, x to the n plus 1 is the main one that you're going to use. Otherwise, you're going to use substitution. And then I have exponential and log functions. And then differential equations. We didn't get to that, but if you do that in College Calc, you'll kind of have a little cheat sheet for that as well. So this is all on the back side of the unit circle. So in case you take College Calc, this will be really, really, really useful for you. Okay?